let's have a look at this here. There's a net force acting upon an object, then A, the object is at rest, B, the object is moving at a constant velocity, the object is accelerating, or D, either A or B.
I thought it said that there is no net force.
One student, I got it.
Wait, correct answer is C.
Correct answer is D.
No.
Is it not? Oh, pardon me. Correct answer is...
Yes, I thought it said there's no net force.
Well, it doesn't. You should maybe read more carefully. The correct answer is C. It is accelerating. You can't say that it's at rest. You can't say that it's moving at constant velocity because it could... it has to be accelerating if there is a net force. The difference between speed and velocity, everybody got this one. Speed is a scalar, velocity is a vector. Good. If an object is moving in a circle, then... Correct answer is D. It is accelerating. It is not a constant velocity because the direction changes. It is the force acting upon a balance. That's not true because it is accelerating. And only the centripetal and centrifugal force are balanced. There is no such thing as a centrifugal force. And if it were balanced, then it would not be accelerating. So the correct answer actually is B, accelerating.
4, I wrote 54 over there, right?
A physics teacher ties an eraser to the end of a string and whirls it in a clockwise circle. If the teacher lets go of the string, then the eraser hits the student in the classroom. If the string is let go and the eraser is at point X in the diagram, then which student in the class will the eraser hit? Oh, I think I've kind of given it away, haven't I, by my diagram up here?
I thought like X, like
54 is wrong.
I thought X was.
Oh, it says 53.
53.
Oh.
Oh.
Should we put X where the circle was? Because I thought X like.
It would probably hit 54 too, right? I should probably adjust my 53 over a little bit, right?
I reckon.
Yeah, but it's definitely not going to hit 44, is it? I got to fix that one bit. In the diagram, which vector shows the velocity at the given point? Correct answer is? Come on. B. The velocity there is tangent, right? In the diagram, which vector shows the net force at the given point? Correct answer is A. The net force is towards the center. It is centripetal. Right? Centripetal. In the diagram, which vector shows the acceleration at the given point? Also D. Centripetal acceleration towards the center. Awesome. I would like to, on the back page there's a couple of questions from the textbook. Do you want me to spend a couple minutes going through those, or how do you want to proceed with the rest of the period? Do you want time to work? Do you want me to show you some more? Show us a couple? Okay. Okay, I'm looking at the textbook here. If you do have your textbook with you, this is section 6.3. I just want to point out a couple of things. The textbook throws a couple of new formulas at you. Mike, you should watch this now.
Okay.
Okay? Remember that we've got V equals 2 pi r over t. And remember that we've got A is equal to V squared over r. And I think that I've given you A equals 4 pi squared r over t squared? Yes, I have, right? I've given you that one. Now remember that frequency, I know there's one more. Remember that frequency is 1 over t, right? Which would mean that frequency squared would be 1 over t squared. Now because I've got over t squared here, that means that I can take this, right, and plug it in there, and what you end up with is this formula, which is really just the same, it's just written a little differently, is A equals 4 pi squared r. Instead of t squared being on the bottom, you can have f squared on the top, which might come in handy if they're giving you the frequency. You could still handle it. You would just have to use that t squared one, you would just have to convert frequency to period by dividing 1 divided by it. You could certainly handle it, but this just sort of gives you that opportunity to do that without having to do that step in between. That's all I'm saying.
Okay.
Okay? And I think the same is true for this one here. That means that this one here, V equals 2 pi r. 2 pi r over t can become v equals 2 pi r f.
Well, see? Okay, so now we go with the flea problem.
Okay, so let's have a look at example number 7 there. A 0.2 gram flea sits at a distance of 5 centimeters from the center of a rotating LP record. Anybody know what the LP stands for?
Oh, they're always like the first couple record cards to me. But what does it stand for?
No, LP is limited play.
Long play, because the records used to be just a single, right? So there's a lot. You get 5 songs on a long play record. Woo! You could spend up to 20 minutes listening. Those were the days. If the record rotates at 77 RPM, that's the kind that my grandparents used to have. What centripetal force must be provided by friction to cause the flea to maintain its UCM?
Do you take kilograms?
So we've got a mass of 0.2 grams. Let's just automatically divide that by 1,000, so it's going to be 0.0002 kilograms. We've got the radius is 5 centimeters, which is equivalent to 0.05 meters. And our frequency is 77 RPM, which is 77 divided by 60 to get it in RPS. 1.28 hertz. And so the question is, what centripetal force must be provided by friction to cause the flea to maintain its UCM? Say again?
No, it's
Res? Frequency is revolutions per second. No, that's right. 1 point, that's right. You're thinking about period,
Oh, yeah.
right? Period would be the other one, right? Yeah. Big T is going to be 60 divided by 77. If you want to do it that way, that's perfectly all right too. 0.779. Okay, so we need to know centripetal force. Well, Fc is equal to mv squared over r. Do I have velocity? I do not. Fc is also equal to, what is it, m 4 pi squared. What did we just write down? 4 pi squared r f squared. 4 pi, not m. Oh yeah, there is an m. 4 pi squared r f squared, but because it's force, I put an m in front. Do I have all those things?
Yeah.
I think I do.
No, where's the other way?
We have the mass, so it's 0.002 pi squared. The radius is 0.05, and the frequency squared is going to be 1.28 squared. I'm going to punch into my calculator.
0, 0, 0.
Oh, yes, one more zero. Thank you. I get 0.00016 newtons,
0.6
or 1.6 times 10 to the minus 1, 2, 3, 4.
times
Forgot the 4 in there,
6.4 times.
so I'm going to take that number just times 4, and I know that it's going to work out, because I just know 1.6 times 4 is 6.4. Yeah, so 6.46 actually. Which is very close to what the book says, right? They get 6.5? Close to it. You want to try number 8 on your own?
Yeah, let's do
Give it a number 8 a try on your own. So here we have, now it says in the book, hopefully, did someone fix it in your book? Because it says in the book 25 gram chestnut, but then they go and they do 250 grams in the solution. So if you haven't, if your textbook hasn't been changed to 250 grams, please do so in your textbook, which of course is 0.25 kilograms, right? With a hole drilled through its center, it's hanging through a long massless shoelace. The child spins the chest at a vertical circle at a speed of 4 meters per second. Hope the kid's wearing safety glasses. If the shoelace is 0.8 meters long, determine the tension of the shoelace at the top and the bottom of the circle. Okay, so at the top, it weighs less, right? Okay, so we've got FC is equal to mv squared over r. And I have to subtract the weight force, right? So I think you should have 0.25. We have the velocity, so it's 4 squared. Oh, we got everything here. This is nice. So 0.25 times 4 squared divided by 0.8. Times 16 times or divided by 8. I get 5. Do you get 5?
Yeah, I got 5.
Okay, and then so we're going to subtract mass times gravity. So we're going to subtract 0.25 times 9.8, and you get, that's where you get 2.55 newtons, right? And if you're going to do it at the bottom, you do everything exactly the same, with one exception.
Oh, look, positive 2.55 newtons, right?
Yeah, but this is negative and not as problem before.
Yeah, it's probably should be,
It
it should be negative because it's down, right? But in this case it says determine the tension. Tension I don't think technically is actual vector because it's kind of like in all directions.
have a negative tension.
Yeah, I don't think so. So I would accept either here. I'm not going to get too excited. This one you just add it on, right? And so you're going to get,
I was thinking when you wrote the first one.
yep, you're right, Mike. Yep. Here we get 7.45 newtons. Okay, good. I think you guys are good to go. We'll test Tuesday. I guess I'm going to have to go on a little bit on Monday with some work and stuff, just because I'd like to get some of that wrapped up before too long. You guys know when your exam is?
Friday the 13th.
Friday the 13th? In the morning. Yep. If you're interested in some extra questions, there's some on page 214, numbers 1 to 4, and 226, 15 to 23.
You gave us lots of stuff.
Yeah, I know I did, but